So hello again in our third talk today. Jochen Christ is going to talk to you about data mesh. Have fun.
Okay. So let's talk about data mesh. I'm Jochen, I'm with INNOQ. And okay, and I want to start with a short story telling you. So last year I was in a project and something happened that never happened before in the last 15 years in my career. Okay with audio? No? I keep talking. Why is the techniques are fixing audio? Sorry. Better now? Do you understand me? Okay, so I move a little bit over here. Okay. No? Okay. I just keep talking.
I think you should speak to the direction of the microphone.
Okay. Okay. Yeah, okay, I get thumbs up. All right. So, again, so I'm Jochen, and we talk about data mesh today. So, I want to start with a short story. So, last year something happened that never happened before in my entire career of 15 years of software development. I was in a team, and we had time. So, the customer had a roadmap saying we want to go international, and my team, I was in an e-commerce environment, and we were responsible for building a software component in the middle or connecting the online shop with the fulfillment logistics. And the internationalization part took us 2 weeks or so in our team, which we just did, and the rest of the year we didn't have any larger goals. So we really had time to do what we think what's best that we can do for the company and for the customers. And we thought, as I said, we were in the online shop connecting with fulfillment, and we had one target that always bothered us, and it was when a customer ordered something like a t-shirt, the company had a problem with no finds. So a t-shirt that was ordered was not found in the fulfillment center nor at the stores offline. And we had to send the customer a sorry email, we didn't find your t-shirt or a shoe, which you were looking forward for. Yeah, sorry, we can't send it to you, here's a 10 euro sorry voucher. And we wanted to reduce the number of no finds in there because we wanted to make the customer happier and we wanted to save money for the company, like revenue. And what we did is, yeah. Okay. So we wanted to reduce no finds, and what we at the same time, some data guys came along and said, "Hey, don't you want to try our new cloud data platform? We just went to Google, and here is BigQuery. Do you want to try out BigQuery?" And we didn't use data science or data engineering before because we were software engineers. So I could write Java code and run things in Kubernetes, but I didn't. Never ever did some analytics with data. And this changed. We just started to bring all our Kafka messages we had into Google BigQuery and started to look what happens just before and just after this no-find situations, this no-find events. And yeah, it was the first time that we really looked into the data. We really looked into what happened with the inventory and stock just before and just after the no finds. We wanted to figure out what was the reason for the no finds. Is there some issue in the processes, or what could we do? And the interesting thing is that we noticed that the days after this no find, when the t-shirt wasn't found, we saw a positive change of inventory. So we got restocked with a t-shirt in more than 50% of the no-find cases. And this was just possible because we could use a BigQuery and had a very efficient way to interconnect different domain events that we have with each other. We could do correlations. And we also could look back the last year, taking all no finds we had, and look what would change if we would not send this no find email to the customer, but wait a little bit, wait 1 day until we send a no find and send it and hoping for getting a stock so we could fulfill the order. And we also calculated what did this mean for the last year, and it was an astonishing number, like 1 or 2 million euro in revenue. So it was totally clear that when we wait a few days, like 7 days, we could save 7 million, multiple millions of revenue for the customer, and have happy customers that get their t-shirts or shoes or so. And it was totally clear for us that we do nothing else but implement this user story, like waiting a bit before sending, sorry, we didn't find your article. And yes, this changed how we interacted with data analytics in the project as software engineers. And that's also the reason why we got into data mesh, because data mesh is what it means, or is applying the principles that we had for software engineering into data analytics. And oh, by the way, someone here is someone here working in data for some kind? So is someone here as a data engineer or data scientist? Okay, a couple. So I don't want to blame you, because what we faced before in software business is that data teams do a great job in analytics, but we often see that they don't scale too much. So they cannot bring analytics to all the teams that are working with softwares. And this is something that we saw in the past in software engineering. So the strategy we usually do is we decentralize software engineering to be able to scale. And we have done this with domain-driven design. So we split up large software into smaller components. This is strategic domain-driven design at core. And we align this with the teams. So we have one team responsible for a domain or a subdomain or a bounded context, if you like. And these teams build microservices or self-contained systems, right? And data must just continue this flow with data, with analytical data. It says the teams that are responsible for software are responsible for analytical data. This is the core principle, and that's the way how to scale data analytics in companies. So data mesh decentralizes data, analytical data, so that domain teams can do data analysis on their own. We do not need a central organization, a central data team that does data analytics. So when we are talking about data mesh, we need to talk about the 4 principles. These principles were defined and coined by Shamak in 2018, and she described a number of principles that are relevant for data mesh. And it all starts with domain ownership. So domain ownership is the first and most important principle for data mesh. And it basically says that the teams, like domain teams, that are responsible for a domain or bounded context are also responsible for the operational and the analytical data. And this is a huge change to what we usually see in organizations, where a central data team that's responsible for the data warehouse or data lake that's responsible for analytical data, building ETL processes, building data science solutions, or building reports for management. So again, that's the first principle of domain ownership is the important thing in data mesh. And this is what we usually see from domain-driven design, right? That's what we all are talking about. We have a domain, we have a bounded context, and we have a clear relationship. The next thing, data as a product, is required as if you have data, analytical data distributed to different teams, how do you interconnect data? And basically, we are applying the principle of API to data. So in the data world, there is no standard for data contracts or APIs like we have in the software world. So we have Swagger or Open API to define REST APIs or APIs in general. And this is something that did not exist in the data world because it was not needed because everything was under control by a single team. So you can think of data products as data microservices, having a defined interface and a team, the domain team, that builds a data product. So when a team builds a data product, the next question is, how do you prevent that each team has to reinvent the wheel? So how to build data in a platform and define interfaces and so on. And the answer for this is the next principle, the self-serve data platform. So basically, the self-serve data platform enables team to make it easy for domain teams to build data products in a consistent way. And the principle of self-service is important to avoid this central dependency aspect once again, right? So we do not want to have a data platform team that is the next bottleneck. It's not responding. So everything the data platform provides needs to be a self-service. And the fourth and last principle brings it all together in kind of governance structures. So what are the rules of play that we want to have in a data mesh? Defining agreements on interoperability, on documentation, on data contracts, and security. Okay, so I will cover that later. And here I have a data mesh brought with me. So this is an e-commerce example. And let's look at the swim line at the bottom, where we have an online shop. And say we have a domain called product search, a domain article details, checkout, fulfillment, and payment. So these are the domains that are derived by the customer journey, what we usually do in e-commerce to define the domains, right? And each of these domains can contain several data products. And let's look at the product search, for example. So the product search domain may provide a data product called search queries, where it includes all the search requests that customers or users did and provide information if one of these results was clicked on, for example. Yeah, and these search queries can be used by a marketing team building the funnel, building funnel analytics. When they connect the search queries with orders in the checkout process, they know if a specific term leads to an order and to a checkout or not. And even if we had a domain returns, they could even check if articles were returned or not. So here we have, at the bottom, we have domains that represent our typical operational systems. And the data products here are pretty close to the source. This is the domain of these services. So that's called source-aligned domains or source-aligned data products. And data mesh also includes a more consumer-aligned view for the business for the business in the company. So like marketing, like management, or controlling. This is what typically has been done by the data teams before, like reports for management. And data mesh now also includes domain teams and the concept of bounded context to these business-oriented views. And what we propose is to also build dedicated teams that support the management or support the controlling with their data requirements. So we call them consumer-aligned. And in the middle, we can have aggregates that build data products that are combining other data products to more aggregated views, if it may be helpful. And also building specific data services like recommendations that may include more specific knowledge in some area, like a recommendation engine. Okay, so this all leads to a proposal of a data mesh architecture. And yeah, in the middle we have the domains. These are central for data mesh. We have the platform at the bottom. We have a governance covering everything, the rules, and we have an enabling team. We will dig into each of these components in a bit. So I talked a lot about data products. So what actually is a data product? A data product is, well, it's like an API for data, but it's an API for data sets usually. So you can think of a table that is accessible for others, or maybe files that contain a set of data. Plus, you have metadata that describes the data set. It's like an API, like what we did with OpenAPI, defining the semantics and the syntax of the data around. And a data product, as it's a product, lives in production, and we have responsibility for production. So the team that provides the data product needs to apply DevOps responsibilities, DevOps principles to the product. So if anything goes wrong, if any of the SLAs drops, like the data is empty, the table is empty for whatever reason, they get notified and they need to fix it. Okay. So if you want to develop a data product, we propose a data product canvas, which you can download from our website. And what we usually start when we think about data products, we usually start with a use case. So what is the benefit of a data product? What is the value for the business or the customer when we have that requires a data product? If you don't have it, you probably don't need to build a data product, right? And a data product can be built based on your source system, your operational systems you have, which are typically ingested into the data platform, or you reference other data products and combine them to more high-level data products. Bring it together. Again, you have output ports, the format, the metadata information, and the observability. Yeah. And yeah, with this canvas, you can do it with your team collaboratively. Okay, next, let's talk about the Selfserve data platform. And data mesh is not a new technology. So data mesh is basically using data services that we already know. So it's using data lake or data warehouse technologies, usually in the cloud. It's not a must, but usually we see data mesh implementations in the cloud only, and relies on one of the typical services. So we have the hyperscalers. Every one of them has data services for both lake and warehouse, file or SQL-oriented databases. And we have a number of specialized companies that provide similar services. Choose one. It doesn't really matter which one you use as your core platform to store and query data. But the second thing in a Selfserve platform is usually a catalog. A catalog is where you can register and find all the data products available. And so, again, here are some data catalog experts available, or each of the platform brings their own data catalog, which limits you to the very vendor you're using. And again, monitoring like data quality and also production availability is important. So we have here a number of tools available that we can use. Okay. Next, let's look deeper into the analytical data. In data mesh, data mesh optimizes for analytical data only. So it's no answer for how to organize your operational data, right? Very important to keep in mind. So what you usually do is you have your operational data, like your Postgres, your MongoDB, or at most times your domain events in Kafka, and you ingest them into the data platform. And we often see some data processing and preparation from raw to a more clean and curated data sets, and finally to aggregations. So, and how do we do this process? Well, the typical answer is here we use SQL. And SQL is something that we as engineers are used to in some way. But even so, there are more advanced concepts like common table expressions, so the Swiss statements, and window functions. And this is something that we need to learn, but still it's SQL, and that's something that we are capable of. What was the question?
Yeah, now I hear myself. If you could go back one slide, please.
Sure.
In the beginning, you talked about each team, I mean, like the value stream team, I suppose, is responsible for the data. And then we have that operational data. And the perspective from the operational, from the team that is responsible for that data is very different from a team that would analyze this data. So it has, like you say, a different structure. It's in Kafka events and so on and so forth. Where do you see the shift in responsibility? So who does the cleaning up of the data? Where does the responsibility end of the value stream team? Because they wouldn't have the perspective, maybe not even the expertise to do that cleanup.
Yeah. Data mesh puts this responsibility to the stream-aligned team. So everything we saw here, and including this SQL statement here, is the same team as the teams that build the microservices and web front ends. So they need to learn how to build analytical data.
Okay, and do they have an incentive? As in the end, will they also be working on the data product?
Yeah, great question. So do they have an incentive to build this data product? Well, a data product is something valuable. So it's something similar to an API. So the question is, does a team have a incentive to build APIs in the first place, right? And with data mesh, data products get the same level as APIs and features in the web front end, for example. So requirements from other teams that want to use this data product, like here, needs to go through the same requirements process, the same backlog prioritization as everything else. Yeah, and if you as a consumer cannot answer the question why a data product you need is valuable to the company, it won't get built because it's not valuable enough. Yeah, great question. Yeah, okay, we have seen this SQL here, and a short excursus. So there's a great tool to manage these SQL statements. And the tool is DBT, stands for Database Transformations. And you can think of it like Spring Boot or React, but for data. And this is how you define your models and build these aggregations we've seen before. And one of the revolutionary things of DBT is that it includes tests. So you can test your data in your source databases, like the raw, define assumptions, what you expect from data, and you can test your models that you create, your aggregations. And you do it on the live data, on the platform. So it works like this one with an SQL statement, and expect to have an empty result set. So if the result is not empty, the test fails. And that's really a great way to ensure data quality in what you have. Okay, just as the next course, I don't want to go too deep into it. And I want to look at another part, and it's analytics. And we are still within the team context, the bounded context of the domain and the domain team. And this is something that provides the team with a motivation, because they are working on their very own domain data, and they can analyze the data based on hypotheses that they know of. So as it's the same teams that builds the operational software, and it well understands all the data they have in the platform. And they can now use the platform to build visualizations and analytics to understand what's going on. And also the product owner has a simple way to analyze if a if a feature that a stakeholder requests provides benefit or not. So what we have done in the project I described earlier is that the product owner challenges each feature request that someone stated and validates it with data. And half of the feature requests got declined as they do not provide enough value for the company. So with data analytics, we were able to limit the features and the user stories we were working on by half just by looking at the data for an hour or two, which is a great motivation to do data analytics. Okay, we have these visualizations, and another way to work with data are notebooks. So like Jupyter notebooks and all the data platforms I described earlier provide some way of notebooks to work with data. And yeah, you can use it for explorative data analytics pretty easy. So we can mix SQL and Python or Scala code to do analytics, to do more data science stuff like correlation analysis, maybe even machine learning if you like to. Okay, next have a look at the federated governance. And federated governance describes a rule of policies, how to have interoperability between data products, security, privacy, and compliance requirements. And this is something that we know from software architecture is architecture decision records. So we can use ADRs, architecture decision records, to describe policies. In describing the context, agreeing on a decision, and describing all the consequences a decision has. And data mesh, or at least Jean-Marc, proposes that every policy you made and stated for your whole team needs to be automated. So Jean-Marc proposes that policies should be described as code as much as possible, to be automated by the platform so that the domain team does not have to think about it. So if you say, if a data column is tagged with PII data, with personal identifiable information, it's not published by default, for example. Then the platform should hide this information, this column, when people are accessing it that do not have the right grants, for example. And the second thing, the federated aspect of data governance, is that it should be defined not by a central team of data architects or data stewards, but by the teams that work with the data all the time. So the members of the data governance group should consist of representatives of the domain teams and the data platform team, and they should be consulted with subject matter experts like legal or security or privacy experts on demand. So this is federated governance. Okay, and this brings us to this mesh here once again, so that we have domain teams providing data and that are interconnectable with each other. Now, let's talk about the elephant in the room. What is the big problem with data mesh that we see? And let's have a look. So 10 years ago or 15 years ago, we all were happy engineers building software. And then someone came up and said, hey, you need to be full stack engineers, full stack developers. You need to build the front end and the back end. And the database. Yeah, so you are now full stack. So you need to learn JavaScript, Java, and let's say MongoDB. Okay, great. Let's do it. And the next thing is, as every time we wanted to bring new software into production, operations said, oh, can't you wait it until the next release in 6 months? And so some cultures clashed, like change versus stability. And our answer was, okay, let's use Docker, let's bring it all together in containers. We are responsible, we get notified when something goes wrong. So we get used to DevOps. Then security experts came around and said, hey, software engineers, you need to be responsible for security because you are the persons that build the software. So you need to integrate SAST and DAST tools in your pipelines. And you need to learn and understand and monitor all the CVEs out there, so the security issues that have then. Okay, security is important. You cannot say no to security, right? So let's do it. And now you DDD guys come around and say, you need to understand the business to build domain-driven software, right? You need to understand the business because it's what you are building. So we are now full-stack BizDevSecOps developers. And obviously, now I come around and say, you need to understand all the data. You need to be responsible for analytical data as well. Yeah, and yes, this brings us to the question if it's capable for software engineering teams to do all these responsibilities. And I do not have an answer for that one, right? So maybe we need to do all this stuff to be great software product developers. Yeah, maybe that's what our profession will be in the next years. But it's something that we need to be aware of. That's really a lot to know, a lot to think of, a lot to learn. And so do not understand the knowledge that a team needs to build up, right? I mean, no presentation today without team topologies. We all can look at team topologies and what they say on cognitive load, which, by the way, is not really covered by the cognitive load theory defined by Sveller studies. But let's just take it to discuss about the topic. And yeah, cognitive load defines intrinsic, extraneous, and germane cognitive load. So the intrinsic cognitive load is the languages and tools and frameworks that we need to learn to do what we do. So the Java coding, the SQL for analytics, and so on. And what can help here is our enabling teams, which I cover in a bit, but also a good choice of technologies. Then we have the environment, extraneous cognitive load. What do we need to do to bring our stuff to production and to use the environment, the platform? And what we can do here is we want to minimize intrinsic and extraneous cognitive load, of course. So we want to have a super simple platform. We want to have a super simple platform for production and for data analytics. And we want to automate everything. And policy as a code was an answer also for this issue. Do not make me need to think about specific things, but automate it by the platform. So we have more time for the germane cognitive load where we can think about the problems, the business issues that we want, how to add value for our customers. Here, as I mentioned, an answer for this is having in a data mesh an enabling team that communicates the ideas of data mesh, act to evangelize and also providing consulting help, examples and best practices to the domain teams that want to go the journey. When you look at the technology acceptance model by Davis and Bagosi, they state that two things are important for a new technology to be adopted. And the first thing is the perceived usefulness. So is a technology useful for me? And this is something the enabling team needs to answer to all the domain teams. Is it useful for me to use the data platform to make analytics and to build data products? And the second important factor is the perceived ease of use. Is it super simple to use the data platform to bring my Kafka domain events to the platform? And this is something the Selfserve data platform needs to answer. So the data platform needs to optimize not for data analysts and data engineers, but for software engineers, for Java engineers or whatever you have in your company. Which is, by the way, not the case for most data platforms available today. Most of them are optimized for Python coding and sophisticated data science stuff, which is also important for the consumer line domain, but not for the source line domains. Okay, so if data mesh should be successful in the company, you need a self-serve data platform and an enabling team that work with it. Okay, next, if you want to look at is data mesh a good fit for you, and are you fit for data mesh? We implemented a simple fitness test, which you can fill out. So you have a number of questions where you can answer, and you get an impression in the first sight if data mesh is something that you should consider or maybe not. So have a look at datamesharchitecture.com/fitness test, and let's discuss the results you have if you want. So, did you have the link? Okay. So, if you want to learn more, there's a great book by Jean-Marc Degani available. And for the German-speaking guys, my colleague and me, we translated into German, so it's available in German as well I think in January. But it's really a great book describing all the principles in more detail. And if you want to get more into the engineering perspective of data mesh, look at datamesharchitecture.com, a website that I co-authored with. There's also a great community, datameshlearning.com, which is a great Slack channel. So if you have any questions, ask there. And also subscribe to the podcast and newsletter if you want to learn more. And all this brings me to my final question, an open question we can discuss during lunch and afterwards. If you look at this DDD teams, microservice, and data flow I proposed, the question is data mesh the logical consequence for organizations that implement DDD in the operational software products? So is this a question to be answered or not? It's an open question, maybe a philosophy. And yeah, that was my talk on data mesh, so we can discuss it, or any other questions you might have.